Locked out from my old Linux server, watch me utilize the hacking techniques of yesterday and break into my own Linux machine step by step. Step 1. Port scanning. We use this method in order to gather information and find a way into the system. Step 2. SQL injection attack, which you perform in a web page. Makes it possible to dump the database and give you all the information. Step number 3. PHP remote code execution. I use this method in order to be able to send Linux commands through bugs inside of PHP code. Step number 4. Password cracking. This is the method for cracking the encrypted passwords by trying all different combinations. And step number 5, the final step, where I turn my user level access to the system into a root administrator access with full permissions by utilizing a buffer overflow attack. Before we begin, hit the subscribe button because you do not want to miss the second episode of this series. And now let's begin. What's up, guys? Welcome to today's show. So today we're gonna learn about hacking. I am locked out from my old server. I do only have the host name, which is prod.drbirch.com. I don't remember any passwords, I don't remember any services it runs, and I don't know how they are configured or what kind of data is on the server, nothing. So today we are going to utilize the hacking techniques of yesterday. So let's begin. Alright, so as I said, the host name of the server is prod.drbirch.com, and that is all I know. And now we also know the IP address of it. Okay, so we need to create a port scanner. So let's just create some directory for all of this. Let's call it hacks. Set it to our home directory. Alright, so let's start coding this single port scanner. So let's call it testport.c. Includes just standard stuff. The ones I usually always put there, and then we can prune it if we need to. And let's also take stdio and one more string.h. Alright, so let's start with the main function. Let's make sure that we have the correct number of command line arguments. So let's see, we're gonna need 2, so we say 3 here. And if we don't have, we print some error message, usage, this. And then we have an IP, and then we have a port. We provide the argv like so. Return -1. Alright, otherwise we want to store this somewhere. So let's create a char IP and unsigned short int port. Alright, so if we get to this point, we are setting IP equal to argv1. We are setting the port equal to, we we need to turn this into an integer. So we can run a to I. Let's do unsigned short int a to I, and then our RB2, like so. Alright, so if we make a connection now and the port is open, it's going to return almost immediately. And same if the port is closed. But if the port is firewalled, then it will not give an answer. And this is going to take like a minute before it times out. So what I'm going to do is I'm going to create unsigned int PID, and I'm gonna fork this into a child process. So we'll set our PID equal to fork, and if we have a PID, so this is the main program, this is not the child. In that case, we want to sleep for 2 seconds, let's say. And then we want to kill this PID if it's still alive. Let's see. Let me just check the signature of the kill. So PID and then the signal. We need signal.h. Kill the PID, and we want to send sig term to terminate the process, and then we wait until it's finished. So either killed or, well, killed in this point. If we don't have a PID, this is the child process. In that case, we want to do the port scan. So let's say test port, we provide the IP and we provide the port. Maybe we can do if test port. So if it's open, in that case, we want to print. IP port. Let's see, HD, I guess, since it's a short int. So we have the IP, and we have the unsigned short int ports. Like so, and then we exit. So that's the basic thing. Now we only need to create this test port function. Since it's returning a boolean, let's include std bool. So bool test port char IP unsigned short int port. Let's also create the signatures up here. So test port with char unsigned short int, and we also have main with an int and a char. Alright, so what do we need for this? We need to have a struct socket address in, and we need to have signed in for the return values, and we also need to have unsigned in for the socket file descriptor. Yeah, let's go with S. So first we need a socket. It's going to be an internet socket and a stream socket, which means TCP. And we can set our return variable. And if this is less than 0, we just return false. Otherwise, we set our S equal to this. Alright, so now we need to fill in the structure. So we have a family, which is AF inet. We have a port, and we need to format this. So we can use the h.s function. We put it into the right order, the bytes, network byte order. By the way, we need to, I think we need to make this a regular int. And then we have the address, and we can use the inet address to format this correctly. And when we have the stock structure, we can do the actual connection. So let's say the return is connect, and we need to provide our S and a struct socket address, and the address of our sock, and size of and the connect is returning 0 if it works. So if we have a positive value, we can close down our sock and return false. Otherwise, we have made a successful connection. In that case, we still let's be dry. We close it first, and then we just check the return value. And return true. Alright, so something like this. Now we just need to add a couple of includes for all the network stuff. So let's check socket first, sys socket.h. And we need the connect. Okay, that's the same. We need the inet address. So we need to add these two. see the wait function. syswait.h. Okay. Lots of includes. Alright, let's see if this compiles. It does. It's nice. So what I'm going to test it against, let's say, let's see, the mail server that runs gmail.com. We pick one of these. And mail servers use port 25, so we can test this against that. So we run test port against this IP and 25, and we get this response. It's good. And what if we have like port 26 or something? Then we get nothing. Perfect. It works exactly as I hoped. Alright, so what ports are we going to test this for? Well, there is a file on most Linux and Unix systems which is called etc. Services. So here is a list of a lot of different ports. So let's say we check everyone up to 100. So let's say we do cat-n on etc. Services. And we go to line 41. So that's good. And now we need to remove this and this, so we only have this port. By the way, we just want to check for TCP. So let's say we grep TCP as well. Okay, so we want to cut this second part first, and let's start there. So we can use awk and print the second argument. So now we have this, and now we can use cut to divide at the boundary of slash, and we want the first fields. Okay, nice. So now we have a list. Okay, we have some other stuff by the top here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe we can just remove everything which begins with let's see, so we have the start of line and then a slash. Okay, so now we just have this white space as well. So how many lines do we have? So if we were to tail 33 of these, then we have the right ports. Okay, so now we have a list of ports. Now we want to take all of these and make a loop. So for I in this, so let's say we do echo and test port, and remember remember the IP now, but let's just do this for now. And then the port number, done. Okay, so now it produces all of these commands. So now we should just be able to execute this. By the way, we need to replace the IP address. So history, grep test port, and let's see which one is it. We don't have it here. Okay. prod.birch.com, like so. So now we remove this echo and we replace this, and let's go. So it takes 2 seconds per port. And it does only provide output when we get a match, right? While it's there we have one. Okay, so port 22 is open. Port 22 is the SSH port, which is used for remote managing a Linux machine. So while this is running, we can try connecting to that. And we get this banner, which is good. That usually means that we are allowed to log in here. So if we somehow manage to find a password, we can just log in through SSH and have local access to the machine. Okay, that's nice. And now it's done. We also found port 80. And port 80 is HTTP, so the web port. That is good news, because the web is often vulnerable to different kinds of stuff. So what we can do is we can tell it to this, we don't get a response, but we can say head/http 1.0, double enter. Then we get some information about the machine. So we see that we're running this version of Apache, the web server, on a Debian Linux machine. And all information we can gather is good information. I'm not aware of any bugs in this version of Apache. Perhaps you know of it, but I don't. However, I'm sure we can figure something out.
Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support.
Alright guys, now that you know that it runs a web server, let's check it out in the browser. So what we're gonna do is we're gonna surf into prod.birch.com. Alright, so here is something we can work with. So as you can see, we have some search bar here and admin login. I usually start by looking at the page source and see if there's something interesting here. Stuff like that could be a link to a different location on the same server. It can be some directory or something we can use, but I don't find anything here other than the admin login link, which we can simply click. And alright, so we can try admin perhaps. Nope. Admin blank. Yeah, that's all I got. Maybe admin password. Okay. But we'll figure this out later. We have a search bar here, so let's try it out. First we can try what happens if you search for a blank thing, nothing. If we type in A, alright, so now we got some results. So this is a server which lists different products like books I've made and courses, stuff like that. But let's go back into the page source, because now we have some more stuff to work with here. Okay, so the links are on another server, but this is interesting. The link to the image is on the prod server in an images directory. So let's see what we find in there. Alright, so here we see two things. We see a couple of files, not very interesting, just images as you can see. But the interesting thing is that we can list the contents of this directory. That might be possible to use at a later event in time, who knows. Alright, so the first thing I usually try after the stuff we have already done, when I have a search bar like this, is I try to put a well, first I usually do this, put a lot of percent signs here, because a percent sign is a wildcard inside of SQL, which is a backend database to a lot of websites. So this will make us see everything in this table. So this tells us that there is a MySQL or Microsoft SQL or some SQL backend, which we might be able to use. And we have already seen, I think, at the admin page, admin.php. So the site is running a combination of PHP and MySQL. That's good information. And now to the next step, I put a single quote here. Because if we get an error now, or some weird result, that will indicate that this site is vulnerable to SQL injections, which is a very dangerous thing. And as you can see, I was right. We get an error from the PHP about the SQL query, and we will even get a part of this query right here. So that's nice. Now we just need to figure out a couple of things, like what I'm interested in is to break into the server, not steal information. But if we are able to break into this admin interface here, maybe we can go further from there, because admin interfaces is usually not very secure after you have gone through the login stage, because the admin is trusted. However, we want to get the password to it, and it's probably located somewhere in this SQL backend database. So we need to figure out the structure and the names of the different tables inside of this database so we can find the password. And how do we figure that out? Well, first of all, we need to abuse this thing right here. And I need to first tell you why we get this error when we put a single quote there. Because when we do a search, the SQL that is generated is something like this. So we want to select something which we don't know, some tables which we don't know the name of, from some database which we don't know the name of, and then it does something like where title, it could be like this, where title is equal to, and then our search string here, and then some other stuff at the end, possibly, like order by ID and things like that. But that's not very interesting. If it were like this, though, we would not be able to search for an A and get results. We would have to search for the exact thing right here. But since we are searching for an A, and this contains an A, and this does too, we know that wildcards are in play. So instead of equals, this is going to be like, and then it's going to have a percent sign in front and behind our search string, which works like wildcards. Alright, so what if our search string is a single quote? Then the entire string is going to look like this. And why is that a problem? Well, it looks for a search string like this, and then the string has ended. So everything which comes after, which is this, is no longer part of the search string. It is part of the SQL query. So we can use this space, since we can affect it, to run our own SQL. And this is what we're going to use in order to get this work. Alright, so let's see what we can do next. I can show you one thing though, because if we just put one of these like this, closing the search string, and then we put a semicolon, which means that this is the end of the SQL command, and then a hashtag like this. Now we get all things from the database, but we do not get an error. And why is that? Because the search string became, so we have this, and then this, and this. So we search for something which is everything, and then the end of this command, and everything which is to the right of this hash symbol is a comment. So this stuff right here doesn't matter, and that's why this is a valid request. Okay, so in some websites, probably most of them nowadays, they don't give us error messages like this. All error messages in production sites are usually hidden. So how do we know if the SQL injection is there? We still can use it, even if it's blind, because we can do something like this, or sleep, let's say 3 is equal to 0. So what does this mean? we're still searching for everything because we have the percent and then this comes. And we are terminating this correctly. So what we are calling here is the sleep function. And what this does is it sleeps 3 seconds per line. So even if we get no output whatsoever, we can still run stuff like this. And as you can see, it is working, I think. Let's see. Or that should be and here, right? Yeah. So now it is loading, and it's going to take 9 seconds to load. And that delay tells us that the SQL injection is there, even though we get no output whatsoever. So that's just one other thing. It's called blind SQL injection attacks. Alright, so now we need to figure out some stuff about the general structure of this thing. So I want to create a query. Let's make a copy of this, which looks something like, so we have this, and then union, which means that we take another table and we smash it together with our first table by the end of it. And it's like it's one. So we can do another select here. And let's say we need to know the number of columns in order for this to work. So let's guess that there are 3 columns. And then we can do this, select 1, 2, 3. We end like this. And we copy from this right here. Okay, so we can see here it has a different number of columns, so we guessed wrong. And let's add one. No. What about a 5th? Okay, now we got the same result, and we got this. So now we are able to grab information from the server and put on the website. So if we look at the source now, we have the 5 that I put, and the 4 and the 3, and here in the images is the 2. So it's not very interesting with this 1, 2, blah, 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 but we can use, if we know the names of some table, we can print stuff from it. So we need to figure out that. And all the tables are located in a database called information schema that contains all the names of the databases and columns and rows and stuff. So let's see if we can't use that somehow. So instead of selecting 1, 2, 3, 4, 5, let's replace, let's see here, which one was the, okay, let's use the 5, we have much room here. So we replace the 5 with, let's see, table name from information schema.tables. Ah, look at this. Now we start getting somewhere. So a lot of this is default stuff, which is contained in every single every single SQL. But here are some interesting. Here are user-defined things. So we have a database called products, and we have one called users. So now we can look for the columns instead. So instead of table name, we say column name, and we take them from information schema dot columns. So now we get the name of all the columns, and that's a lot. So we need to find the user-defined things, because a lot of these are default as well. Luckily, a lot of them are in caps, but not all. So let's see here. Here. So this must be from the users database. I mean the users table. So we have username, password, admin, an image and title. That sounds like it's from the product. But these three must be from the users. So that's very interesting. So instead of using this 1, 2, 3, 4, we can keep the 1, 2, because we still need to have 5 of them. And we want to know the username, password, the username, password, admin from users. Look at this. There is a user with a username admin and password orange, which is an admin. Nice. So before we try it on the admin interface, let's see if we can use the same. We can probably not do that, but let's try it anyway. See if we can connect to the server and log in as admin to prod.birch.com and use the orange password directly into the administration SSH connection. So we try orange. Too bad. And maybe we can try the root user as well. No, it doesn't work, because orange is too simple of a password. It's not allowed. It needs to be some capital letters and some numbers and some stuff. But since it's directly taken from the database, it must work on the admin interface. So let's go into here and we'll log in with admin and orange. Bam! We are in. We are in the admin interface. So after the break, we're gonna look through what we can do from here. So see you just in a bit. Alright you guys, welcome back. So I switched to my Windows machine for the next part. Doesn't really matter, but let's do it anyway. So let's see here. Let's go back to the website, and it was prod.drbirch.com, and we go to the admin login, and we log in with admin and orange. Alright, so now we're into the admin interface, and as you can see, we can't do a whole lot from here, but we can upload images. And if you remember, let's search for something here. These images, they are located inside of the images folder right here. So probably when we upload here, it's going to end up in this directory. So let's begin by trying it out. So let's see. Let's just download and re-upload one of these. So save link as, I guess. So let's go to the desktop. And here, and let's call this something else. I don't know, image PNG. All right, so let's go to browse, and we pick this one. And we click upload and see what happens. Okay. So if we go into here and we upload, update, now we have image.png, and it works. So we are able to upload images. Does that mean that we are allowed to upload other stuff, other kind of files? That would be very interesting indeed, because if we were to upload a PHP file, so let's create one. So let's call it hacks, and let's just put something in here for now. We can run PHP info, which will display different configuration settings and stuff. And then we rename this file to hacks.php, because the PHP server software works in such a way that every file which has a .php extension that we can reach through the web, when we load that file in the web browser, it's going to interpret it as code and execute it on the server. So if we are able to upload this file, we are in very good hands indeed. So let's see what we can do here. Right. So let's go to browse, and now we take this hacks.php and upload. File is not an image. Sorry, your file was not uploaded. Let's double check. Nope, it ain't here. All right, so let's think about this. How does it know if it's an image or not? Does it only look at the file extension? In that case, we are in trouble because we need it to be .php. We can't really do anything about that. But it might also be the case that it does not check the file extension, but it actually checks if it's an image, if it contains the correct image format. So what if we were to take a proper image and modify it? So what I mean is,
we delete this hacks.php and we take this image and call it hacks.png instead. Then we open this with a hex editor. I'm using Notepad++ here. You can use VI or Vim as well as a regular hex editor. So most image files works like this. They have two parts. In the beginning there is the header, which contains stuff like file size and aspect ratio and resolution, possibly colors and stuff like that. Information about the file. But this is just a tiny fraction of the file. The rest is bitmap data, if it's a bitmap file format, which this is. And here we just have a lot of bits where a specific number of bits is 1 pixel on the screen. So it just tells, okay, this pixel on the top left corner is going to be this color, and next is going to be this, and so on and so forth. So we cannot really modify the header, but if we go somewhere in the bitmap data portion of the file and we modify it, so let's go maybe 75%. And then we go in here. The good thing about PHP is it doesn't matter what stuff is in the file before the code or after the code. The only interesting thing for PHP is that it finds this PHP tag. And then we can put some code here like PHP info. And we close this like this. And then it's going to look for this in any file and it's going to treat it as code. So if we're able to upload this with a PHP extension, we are in good hands. So let's rename this. Let's call it hacks2 and we call it PHP. But it is an image file. So hopefully this admin interface is going to treat this as an image. So we go into here, we pick hacks and we upload. Okay, would you look at that? So inside of here we have the hacks2.php, and if we click on this we see a lot of these weird characters, because that's the part of the file which is the image part. But if we scroll down to where we put the code, would you look at this? Isn't this beautiful? Even the HTML works. And here we see a lot of information about the machine. And even better, we can execute any PHP code we like this way, which also means that we can execute the shellcode, because in PHP there is something called I think it's system, which runs a Linux function, like a Linux command. There are also something like pass through or something like this. So let's see if we can figure out a way to actually run some Linux commands. So let's call this, let's call it hacks3. And let's edit this again with Notepad++. And let's search for our PHP part. Where is it? It's hard to see on the screen. I don't know really what it's... there it is, okay. Okay, so here is our code. So instead of using this PHP info, what if we were to use pass-through, and then we run some Linux commands like id, uname, and I don't know, let's list some part of the file system maybe. Yeah, let's try this. All right. So, let's add something more to it. Because we need to find the part. If we have something which looks like this, it's very easy to find it inside of the file. But if we just have some Linux text output, it's not very easy. So let's just add something like echo. Okay, I did not intend to do that. Let's add something like echo foobar. Then we can search for foobar. Alright, so let's upload this thing. It worked. So let's see what Hacks 3 has in mind for us. Let's search for foobar. Look at this. The formatting is not really great, but here we see that our user ID is www.data, which is common for the web server to run as. And we also see some information about the actual machine. And then we see it's very hard to make out what this is, but what we see here is, well, this is another machine, not the same, but if we run ls on /, we see a lot of stuff here inside of the root directory of the file system. And that's what we're seeing here as well. So we can run any Linux command we'd like. So what do we want to run? Well, I want to be able to log in to the server, even if we don't have a root login. I want a proper shell. So that's always a good place to start. So let's rename this to Hacks 4. And let's edit, search for foobar, and we can keep the echo foobar. Maybe we can even add some spaces in front. Let's see, we can't use these. Let's do this. And we don't need this any longer. Okay, so what command do we want to run? What about cat / etc. password? If this works, we will get the password hashes of the users, and we might be able to crack those. All right, so let's see here. By the way, on newer machines, the last 20 years or so, this file no longer contains any passwords. Instead, there is a shadow file which contains the passwords, and that is not readable by regular users. But since this is an old machine, probably it will be in clear text visible in this file. All right, so let's save this. And let's upload our fourth file. It worked again. Let's see what we get. So let's search for foobar. Okay, what do we have here? Here we see a lot of the user accounts. As we can see, most of them is just local special users, but we should probably have some regular user. Here, Birch. This is user ID, and this is the password hash. So this is not an unencrypted password. It is encrypted in a one-way encryption. So we need to differentiate between symmetric encryption, where we have a key. So if you encrypt something with a key, you use the same key to decrypt it. That's symmetric encryption. But this is hashing. And as an example, if you have something like 4 times 2 times 9 times 4, so what will this be? This is 8. 8 times 9 is 72, right? Times 4, 150, 300, minus 4, 296 or something. I'm not entirely sure, but you get the point. So if you only have this number, you cannot produce these, right? Because many different combinations of numbers is going to create the same output. And that's how hashing works. So instead of putting the clear text password in the password file, you hash it. So you turn it to something like this. And then when you try to log in and the system will authenticate you, it cannot decrypt this and compare with the password you are providing. Instead, it takes your password that you are providing, it encrypts that the same way with the hashing. And then it compares, does it produce the same hash? If it does, then it knows that it's the correct password. So that's how it works. So in order to be able to turn this back into a password, we need to try let's say we have a list of a lot of words, right? So, I don't know, let's say pig, dove, cat, dog, etc. And we hash this, and we get some hash, and we compare it to this. And then we do this and this and this until we get something which produces the same result. And then we know that that is the correct one. So that is what we need to do. We need to do some password cracking.
But that will be in the next episode. But don't leave just yet. I have a good video recommendation that I want you to see by the end here. But I really hope you like this episode. Please like and subscribe. And thanks for watching. Thanks for tonight.